Every day, we generate massive amounts of data, documents, chat logs, transactions, and even notes. But most of the time, this information just sits there, hard to navigate and even harder to really use. So when we try to work with it, often with things like RAG pipelines, we end up treating it as fragments, chunks of text, disconnected pieces. And to be fair, that approach works. For a lot of use cases, it's actually good enough. But as the data gets more complex, especially in more demanding or professional settings, it becomes harder to rely on just similarity, because the system is still operating on fragments, not really on how things relate to each other. If you look at how people study or understand something, it's usually a bit different. You read through it, extract key concepts, connect ideas, build some kind of mental model, maybe take some notes and draw diagrams. Something you can actually pick up later and then navigate. BrainAPI takes an approach more like that. It processes data from different sources, e-commerce logs, chatbots conversations, company documents, and builds a structured, connected representation of it. So instead of only retrieving text, you are interacting with something that has context behind it. In this video, we'll go through a simple example. We'll create a new brain, ingest a research paper as PDF, and then query it using Claude Desktop via MCP. And then we'll run the same thing through a standard RAG pipeline in n8n and just compare the results. So let's get started. The first thing that we need for our project is a new brain, and we are going to create a new brain on the cloud via the BrainAPI dashboard. And here we are on the BrainAPI dashboard, and the first thing that we need before creating a deployment is to be part of a team. And we are going to create a new team named Test. Then the next thing that we have to do is to create a new project, and a new project that will hold our brain, our deployment. And we are going to call this project Demo. And then we are ready to create a new deployment. This deployment will be called Documents MCP. We are going to create a free deployment. Let's create it. And here we have it. We have a URL that we can use to connect to our deployment. We have a personal access token that we can use to authenticate ourselves when connecting to our brain. Now that we have our deployment, we can add data to our brain, and we are going to do it on this page, the enrichment page. And for this project, we are going to use PDF documents. Specifically, now we are going to upload this research paper, PDF, the Graph R1 research paper. So let's upload it to our brain. Okay, so we have uploaded successfully this PDF to our brain. Now BrainAPI is going to read and create the structured network of information for our PDF, and we just need now to wait until BrainAPI has finished reading our document. We can see that after a while the document has been broken down into a structured network of information. And the document actually has been broken down into 570 nodes. So let's try to see all of them. And here we have the paper node, so the main node regarding the research paper that we added to our brain. And we can see a bunch of different information around. And actually, we have this structured network of information that represents what the document, so the research paper, is talking about. Now let's try to do the same thing with a standard RAG pipeline in n8n. Here we have an n8n template already open, and since this is not an n8n tutorial, I'm not going through all the details on how to create a RAG pipeline on n8n, but basically what this does is takes a document, creates a vector embeddings via the OpenAI embeddings API, stores these embeddings and the relative chunks of text into the memory, and then when the large language model needs more information, because we are asking for more information, uses the search tool to search into the vector embeddings for relevant chunks of text. And for this experiment, as I said before, we are going to use the same document we used before. So let's start this pipeline. Let's select the same document as before, so the Graph R1 research paper, so this is the same as before. Okay, let's upload this. Okay, so we have added the document. This is going to create the vector embeddings, and we have created the vector embeddings for our document. So now we are going to test the retrieval, both from the BrainAPI side with the MCP server connected to the Claude Desktop, and here by asking the OpenAI API more information about the document that we've added. Let's start by choosing what to ask to our agents. And we are going to do this by taking a look at the GraphR1 document and finding something interesting to ask to our AI. And let's take a look here. So I think that something interesting might be the agent action space here. So we are going to ask, what is the agent action space to our agents? Let's open the chat here and ask, what is the agent action space? And let's see what we get back here. Okay, this is a pretty straightforward answer. And now let's connect the BrainAPI MCP to Claude Desktop and try to ask the same thing to Claude Desktop. Here you can see that we are back on the BrainAPI dashboard because we have to copy the URI of our brain, of our deployment, and the personal access token that we will need to authenticate ourselves. Here we need the Claude Desktop client, and to add an MCP server we have to go to the settings, developer, edit config, and this is going to open the path on your computer where you have the configuration file. I already prepared the configuration file, so I'm going to show you how it will look like. You might not see the same initial file, but the important thing is that you add the BrainAPI configuration here into the MCP servers, and this is what you need in order to connect to the deployment. Here I'm using an npm package to connect to the BrainAPI deployment. Here we need to add /mcp to the URL in order to connect. And here we have to add the personal access token into the bearer token key. And let's save this configuration file. We have to reload Claude Desktop. We are going to do it here. And we are ready to start chatting with our brain. And let's start by asking the same question we asked to the N8N agent. So what is the agent action space? And here I have to specify to search into our MCP. That is both the name that we added to our configuration on the keys, so this one, but also here the MCP name. And so let's specify to search here. Search into, because otherwise Claude might search on the web or search into his personal knowledge bank. So let's ask this question here. Now it's using the tools from the BrainAPI MCP. It's searching on the graph about the agent action space. Let's give it some time. And here we can see that it's navigating the knowledge, not just retrieving chunks of random text. And here we have an answer that is actually much more deep and precise on what the agent action space is, also with examples. And if you remember, the answer that the N8N agent gave to us was much more synthetic and simpler. And this goes much deeper into what we asked. I want to do another example here. And for this example, I already prepared something to search into the brain. And we are going to search a name of our searcher, in this case, Luc Zettler-Moyer. And so let's start by asking to the N8N agent, who is Luc Zettler-Moyer? Now, the agent is going to search into his knowledge base who he is. Okay, so he wasn't able to search and find, he was able to search but wasn't able to find who Luc Zettler-Moyer is. Now let's try to ask the same question to Claude. So who is Luc Zettler-Moyer? Yeah, still we have to specify where to search. Documents MCP. And now it's going to search into the brain who Luc Zettler-Moyer is. Now we can see that it's using the tools. Okay, so we have an answer, and we have a successful answer because Claude was actually able to retrieve from the brain who Luc Zettler-Moyer is, and also to find more information about him. So we can see also that he is one of the publishers of the Retrieval QA, and even other publishers here. And so yeah, here we can see, especially with this example, that BrainAPI is able to find more precise information about the things that we are asking. And even with much simpler queries, so for the agent action space, where the agent on n8n was able to provide us an answer, we can see here that BrainAPI can be much more accurate when providing the answers that we need. So yeah, this was a simple example on what BrainAPI is capable of. To start using BrainAPI, I suggest you to send us an email at hello@lumen-labs.ai before creating an account into our dashboard, because this way we are going to give you free credits and help you to be more successful with the integration of BrainAPI into your stack. So make sure to reach out to us before you create an account yourself on our dashboard.